Hi, here we are given that let ABC be a right angle triangle with hypotenuse BC of length 20 cm. If AP is the perpendicular on BC, then the maximum possible length of AP in centimeter is how much? So this may look like a triangle question, but it is more of a circles question actually. This is a triangle ABC. Okay? Let's say the right angle is at B. The hypotenuse, right angle is at A, the hypotenuse is BC. So this is the right triangle ABC. Now AP is a perpendicular drawn on BC. So we have to figure out the highest possible value of AP. The length of BC is given to us as 20. Fine. So let me redraw this figure. Let me draw BC as a horizontal line. This is BC and this will be a point, let's say A somewhere here, such that this angle is 90 degree, point A. Now let me do one thing. Let's draw a circle with BC as the diameter. So we know if BC is diameter and diameter makes an angle of 90 degree anywhere on the circle. So basically BC is making an angle of 90 degree over here. So this circle with BC as diameter will pass through A for sure, because this angle is 90 degree and this is going to be the center of the circle, right? So basically what happens here is, with BC as the diameter, the third vertex of the triangle will lie on the circle, and this circle is the circumcircle of this triangle. Now if we draw a perpendicular from A to this side BC, what will be the highest value of this perpendicular? Let's see. Now this is one way of drawing the figure. I could have also drawn the figure something like this. A could have been somewhere here. If this is BC, A could have been here. And the circle in that case will look something like this. Although A is very close to BC, but still the circle will pass through A, because this is making an angle of 90 degree here. So A could be here, 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 or anywhere here. So your triangle could be something like this, or it could look something like this, or it could look something like this. All of these will be right triangle with vertex A. So if you draw a perpendicular from A to BC, in this case this will be the length of AP. In this case this will be the length of AP. So think about it. When will AP be the highest? AP will be highest when A is immediately above the center of the circle here. Right? When A is immediately above. And what will be the length of A in this AP in this case? If P is at the center itself, the length of AP will be same as the circumradius of this triangle, right? And also we know circumradius of a right triangle is half of hypotenuse. Half of hypotenuse is 10. So basically, what this effectively gives us is, if you want you can remember this. In a right triangle, if you draw an altitude from the right vertex, its length will be highest when P, or this point of altitude, is the midpoint of the hypotenuse, right? We know midpoint of the hypotenuse is the circumcenter of the triangle. So if AP is bisecting BC, in that case AP is going to be of the highest length, and that length will be half of the hypotenuse. Circumradius of a right triangle is half of hypotenuse. So the answer here must be option A, 10.